To examine how we can set up this automatic drift detection, let's take a look at the Wallaroo Operations Center UI. Here, I can see what pipelines have been created, and if I click into one, I can see various information such as version history of this pipeline. If I go over to my Insights tab, I'll be able to see what assays have already been created for this pipeline, and I'll have the option to create more. Assays are the term in Wallaroo for the automated drift detection tests that the platform provides. I can create an assay to automatically monitor any input or output variable of my pipeline for drift. So for this example, I will monitor one of my output variables, and then I can go ahead and actually select my baseline that I want to measure drift from. People here are often using training data and uploading that in order to set a baseline for their drift detection. Next, I have a lot of advanced settings that I can control, including how often my automated drift detection runs and what metrics it uses to quantify drift. I can also specify the threshold at which I want to receive an alert that drift has occurred, essentially a measurement of how different the two distributions have to be for me to consider it problematic drift. Here I can see any assays that I've created for my pipelines, and we can see that I have one on the input of this pipeline, as well as one on the average confidence, which is an output. By default, these assays will show aggregated data across all of my edge devices, but I can also segment by specific devices or groups of devices if I want. Now I can take a look at a historical period for one of my assays. And what I've done is simulate drift by feeding one of my edge devices blurred images in order to simulate a mechanical failure in one of my cameras causing faulty input data. As more of these blurred images trickle in over time, I can see the measurement of drift slowly start to increase until it crosses my threshold and begins throwing alerts. I can also click into any one of these data points to see a little bit more detail about how the distributions are different. And as I click into the data points where more drift has occurred, I can see just how different the distributions have become. Looking at the same period for the assay I have on my outputs, I can see a similar pattern, though this occurs a little slower. This makes sense since I'm simulating a defect that degrades the quality of my input images. I'll notice that effect first in the inputs and only a little bit later on in the outputs. This underscores how, in a world where I'm managing many edge deployments, I have to think a lot about what drift looks like and account for things like mechanical failures in addition to actual changes in my input or output space. And so today we've seen how we can deploy computer vision models to the cloud and to the edge and have a central way to manage those cloud and edge deployments, as well as a way to monitor things like drift centrally over time using Wallaroo.